All right, good afternoon, everyone. This is the Trusted Enablement, Trusted Execution. I'm also in a lunch coma. How about that? Trusted Execution Environment Provisioning Group. So just in case you're looking for the right session. So we are still looking for 2 note takers. We do have Etherpad also, so please, anyone? Can't really get started unless we have at least one. Adam, hiding in the back. Can you help? Will you help? Okay. Thank you. And I want to thank Pete also for volunteering to be the Jabber scribe. So with that, let's get started. I'm not going to read the whole note well. Hopefully, now that it's the second day, you know all of the rules behind that. Okay, so what we wanted to do is the blue sheets should be going around. We're all set with the note takers and the Jabber scribe. So for the note takers, let me know. I think it would be good if you can do the notes in Etherpad. That way folks who want to follow it can follow what's happening also through there, and it might be easier for us to grab it at the end from there as well. Okay, so for the agenda, what we have is, we're bashing it right now. I'll have Dave review the current milestones. So welcome, this is our first official session now that the group has been approved. We are an official working group. Yeah, how come we're the only ones clapping? So we'll go through, how many are coming in for the first time to TEEP? Ooh, quite a few, so good. Okay, well, kind of good. So we'll have Dave do review both of not just the charter milestones, but of the problem statement of what we're trying to address here within TEEP, along with the use cases. And then we'll have Hannes follow with the architecture, followed by Ming, presenting the proposed starting document for the solution protocol. And then we'll close loop with, there's some questions that we have vis-a-vis the architecture direction, and then we'll wrap up. So any questions with regards to the agenda? If not, we'll get it started.
So astute observers will notice that there's some issues in the milestones as they are listed on the charter page. There's actually some errors on there. Besides one that is likely to be overdue, there are 3 errors that an astute observer will say, well, this is actually impossible. There are typos in here and we need to fix these. And that's the point of this agenda item. Okay. There actually have been ones, but if you look on the website right now, this is still what's on the website right now. So we actually wanted to figure out if you believe what dates it should be, because I think the chairs, we've discussed a date in the past, but we want to hear what the working group thinks. And so there's initial ones to adopt at this meeting, an architecture document and a solution document. Right, the first one is red because we don't actually have a document that's an architecture document. There's architectural stuff in the proposed solution document, so there's some material for one, but we don't have a separate document right now. That's why it's unlikely that we will adopt an architecture document at this meeting, and that's why that one is red. The other 3, you notice that there's things like progressing a solution document at the ISG for publication that occurs before beginning the working group last call on it. And so obviously those are in errors, right? So we need to resort these and come up with what the dates are. So the one that is actually more likely to be fine is probably the begin working group last call for architecture document in December. Maybe we can argue that one is okay. But really the things are, we have to do 2 working group last calls, 1 for each document, okay? It probably makes the most sense for the architecture document to precede the solution one, but those in theory could happen in either order as long as there's general consensus on what the content is, right? So you can see right now, December for the architecture and July of next year for the solution document for working group last calls, okay? But then there's the progressing them, where right now you can see it's progressing the solution document before the architecture document. So anyway, what do we want the dates to be? So let me first ask for the date that's not in red. do we think that December, for those of you that have been participating, if you don't know, that's okay, right? Just if you have ideas on what you think it should be, because we're going to set the goals between us and the ADs. We just want some community input, okay? I don't know if we have a straw man date to throw out there, or if we want to invent one on the fly here. So right now, I would say the begin working group last call for architecture, December. Sure, let's see if we can meet that. Maybe we want to co-locate the working group last call for the solution document in that same time frame. We can always update them later. I see the author of that document nodding. Do we want to say December 2018 for the working group last call for the solution document? We may not know enough to know for sure whether these are going to be met yet. We got to put something where the dates actually are in order and make sense, right? So that's the goal right now, okay? And then the progress in the IESG would typically be at least one IETF meeting after that based on how long normal working group last call comments take to resolve, okay? And so then we'd be targeting for, let's say, between March and July 2019 for the progressing to IESG, if we're going for December for working group last call. Any comments? I see a couple nods up in front that that's reasonable. Okay. Okay.
You as the potential authors for the architecture document, so.
If it takes a while, then we may have, WebEx interim meetings or something like that to make sure we're making adequate progress, and we'll checkpoint and revise the milestones as needed. Okay, it's just we want to update them now, like right after this meeting, update them so that they actually are in chronological order and make more sense so that we don't confuse people. So.
Yeah. The gating factor right now is we don't have an architecture document, so that's the first order of business is when can we get one so that we can have review for adoption.
So unless something magically appears between now and the end of this week, then we can't have March as being an adopted architecture document. We'd set that to be, I don't know, May? I don't know. April? Okay, yeah. Nancy's arguing for April, and we armed with some people to help.
Well, I'm being aggressive, but that's presuming that the authors are.
Having aggressive goals is good. Having aggressive goals is good. It gives us incentive to make progress. So, okay. We'll do that. Okay. No other comments? Great. Okay, so I think I'm up next then. Not that one. We've got to switch to their deck.
You're going to the problem statement and use cases. There you go. Okay, so I saw a bunch of people raise their hands that they were not at the BOF, right? Can you raise your hand again if you are not at the last BOF? Raise your hand. Just going to kind of get a sense of the proportion of the room. At least half of the room was not at the BOF. Great. So what I'm going to do now is I'm going to repeat the problem statement presentation at the BOF, the one that we gave before it became a working group. Now it's a working group. This is what we talked about at the BOF that motivated what went into the charter. Okay, and the purpose of me counting the hands was to see how much time I should spend on this. And since at least half the people were not there, that means I'm going to go about at the same rate as I went to the BOF. So for those of you who are at the BOF, this is a refresher because all the slides are the same. Okay, so this is all about provisioning a trusted execution environment. So the first couple of slides are about what's a trusted execution environment, why do we care, why are they important, okay, in case you're new to that. The background is that hardware-based security is desirable. You can do stuff in hardware that's stronger than what you can protect just via software. And so you have things that are widely deployed in the industry today, different types of chips. Even the laptop that I'm projecting these slides from has a TE chip in it, probably many of your phones. You can argue that a lot of your credit cards and debit cards have passive TEs on them and those chips. Okay, and so this concept of hardware-based security is actually adopted in other standards bodies, Global Platform being one of them that is big in the payment industry and so on, and that we have a bunch of interactions with, but it's not the only one. And so this notion of TE is already widely used in many different contexts, payment being the most prevalent one that at least consumers are familiar with, but it's not the only one. What do we call a TE? We're provisioning something. What's the thing that we're provisioning, right? Because this is vendor agnostic, there's many types of TEs. Examples would be SGX from Intel, TrustZone from ARM, different secure elements that exist out there. All of these are things that are TEs under some generic definition. And so the most generic definition that we know of, that's what is a TEE, and everything else is how good can each vendor TE chip meet the following requirements. What a TE is it's anything with these three properties. Okay, it has something that's a unique security identity, so you can't just copy it or clone it, right? It's unique in the hardware. For example, a private key that's baked into the firmware or into the hardware. Second requirement is that there's no code that executes in there except for code that's authorized in some sense of authorized. Right? You can't just put
buffer overrun, malware in there, or whatever, like you can in a normal rich operating system, right? It's got some hardware enforced protection that only code that's allowed code can possibly execute in there. Okay? And there's different techniques for doing that, but that's the general idea. And the third one is that any of the data that's used by that can't be read, at least unencrypted, by code that's outside there. So it has some isolated storage in memory or flash or whatever it is, right? So you have any data can't be read by code that's outside. Anything that meets those three can be called a trusted execution environment. And if you're provisioning one of those things, that's what this working group is about. Where in a security threat modeling sense, any compromise of things that's outside of there doesn't inherently compromise or affect what's inside there, right? So if you have a rootkit, your kernel gets compromised or whatever, it still can't touch this code, this memory, or whatever, okay? That's what the benefit is. Here's an example picture from the global platform architecture that illustrates, since I said this is not new, right? It's been out there. Global platform has this nice diagram that shows on the left side there your rich execution environment. So that's like your normal OS or whatever. And on the right side is your trusted execution environment. And you can see this kind of isolation there where each one of them have their own, the public RAM and the trusted RAM and so on. Okay, so sort of two sides. And the things that run on the left side are regular applications. Maybe you call them rich applications. Maybe not if it's a rich execution environment. The thing that's on the right side, if there's an application that runs inside there or a piece of an application, that thing is called a trusted application. So when we use the term trusted application, we're talking about a piece of code that's running inside the TEE, okay, that might be interacting with pieces of code that are over in the REE side. So despite having those chips that are widely available and in many of our laptops and phones and stuff, the number of apps that actually use them is relatively small, right? If you compare it to the number of apps and app stores and stuff, it's tiny, right? Why is that? It's hard. That's why we're here, at least in part of why we're here, is to solve part of that problem. Again, 3 use cases for those apps, right? 3 types of things that typically use trusted applications today. I mentioned the payment industry was one, right? So I only want to, charge my credit card. The thing that has access to, the keys or the IDs necessary to do that might be running inside of a trusted execution environment. Second example is inside of an IoT device. And so if we think about a safety critical system, a traffic light or a chemical factory thing that has potential dangerous chemicals in it, right? Only authorized code can do that dangerous thing, like change the light from red to the traffic light from red to green, right? Only authorized code can do that. Third example of TE applications is in cloud computing, where if you have a TE as a service type of idea, then the data and code that is being used by, say, a cloud tenant, well, that's kind of interesting, the flickering, cannot be accessed or read by the cloud hoster, right? So you can use a service like, Azure, AWS, or whatever else it is, but the tenant has access to it and the hoster does not. Okay. That's another example of a TE. Okay, those are things that, again, you want to provision, install, or whatever. So this is the one slide version that shows where TEEP fits into the overall picture. This is the same slide that we used for our one diagram for the BOF, okay? And so this is kind of the entire ecosystem, and what this working group focuses on is specifically, again, maybe line number 4 is in scope. Everything else is context and out of scope except for larger context discussions, okay? So if I walk through this one, since this is the most important one to understand, there's a number of different entities that are in this picture. And we'll talk more about those in the use cases here. But you can see there's an app developer on the left. There's an end user on the right. And in this particular example, right, it happens to be an end user. There's a little phone thing there. So the end user might be the guy that's holding the phone. Down on the bottom, there's a trusted application manager. And we'll talk more about this. But this is basically the entity that controls what is allowed to be running inside that TEE chip. Okay, and there's different variations of that, which we'll talk about. There's one slide version. There's some entity that says what's okay to be running in that chip and what's not. And the trusted application manager is the thing that has that ability. It's the manager of that information. And so what happens here is that any particular application that gets developed, say an application that has a trusted component, and maybe it has a rich component as well, gets authored by the app developer, and that needs to be somehow at the end of the day installed on that machine on the far right. Okay. Might have a trusted piece that goes on the inside. It might have an untrusted piece that goes on the outside of the TEA. Okay. And so the untrusted piece, the regular application, if you will, follows the same path as whatever it does today. In this example, it goes to some app store it gets uploaded into. That's the one in the middle. And in this example, maybe the user downloads the normal application via the App Store, right? So that's the lines 2A and 3 for the regular application, which is not about the trusted application yet. How does that get into the TEE? Okay. Well, there's at least two different ways that can work. Okay. One way that can work is following line 2A. The application, the trusted part, might be bundled with and shipped as part of the regular application, and so that's the kind of the 2A example as it comes down. But it still has to get authorization to get installed inside there. So that's what the leg from 4 is, to say when that gets down there, is this okay to stick inside that trusted environment or not? So he does this line 4 check to say, is this okay? And then it goes in and runs in step 5. The other path it could go through is there might be a different distribution mechanism based on the use case, the business relationships, or whatever. And so the binary and or configuration data, keys, whatever, goes along line 2B, over to the Trusted Application Manager. And so when the rich application in number 3 wants to use the trusted application, or potentially before then if it's pre-installed, right, there's some check to install the trusted application or the data that goes with it, the provisioning of it, and that's what line 4 is. Okay? And again, we'll go through a couple of use cases in a second. But the main point is the way that the actual binary gets distributed could be either of two paths. Okay? And line 4 is this negotiation that says, is the following thing okay to run inside this trusted environment or not? And we'll talk more about the different use cases of that, but this is the one slide version. Okay. And all of these is based on the notion of public key cryptography. And so anybody that needs certificates has some CA, and that's why the CAs are at the top. It's just using normal public key cryptography. Okay, so there was this slide that we went through at the BOF, and the use cases slides later kind of expand on this, and in my opinion are slightly easier to read, but I'll talk to it here anyway. So the point here is there's a number of different entities that have issues to solve. Okay, there's a bunch of questions here from the device owner and the manufacturer, and I'll break this down onto one slide per entity in just a little bit here. It says each of these have some gaps today, right? It says why is it that you don't have zillions of trusted apps out there right now compared to zillions of normal apps in an app store? Okay. All of these issues that exist today. And so, for example, if we look at, I'll pick one or two of the things on here. So let's take app dev in the center, right? If I'm an app dev, right, how do I'm running an application that's meant to run on a specific type of chip, right? Here's the version that's meant for this type of architecture. Here's the code that was written, was compiled for a particular thing. How do I know it's going to be running inside there and not some emulated one which is going to be leaking those secrets and attackable or whatever? How do I know it's actually running inside the hardware? And I'm going to craft the binary to be run inside, the real hardware thing, and I want real protection, right? That's an example of one. Similarly, another one would be the device owner. How do I know whether this is a trusted application who actually want to let it in there, or this is actually some malware? How do I know that? Okay. All right. So the problems today can be summarized into an adoption gap for app developers, right? How do we make it easier for people to write trusted applications instead of rich apps that can be compromised whenever something in the rich execution environment is compromised? Okay. How do you get something that gives that hardware enforcement against the compromise? How do we make that be easier? Today, there's many different device manufacturers, multiple TE chip vendors, many device types, and so does that mean you have to write an application and the management tools for them for every single one of those? Or can we get some standardization so at least your management systems and the way that you send the keys and things can be standardized? So that's the lack of standards to manage them. Today, there's various proprietary techniques, and the goal of this is to have a common standard such that there can be a tools ecosystem that springs up independent of which chip vendor you're talking about. Okay. I think that's the last slide in the problem recap. Okay. So now I want to switch over to the use cases deck, which is new. So this is the break that says these are the slides we talked about at the BOF that then inform the charter text. Okay. The charter text is still a bit ambiguous in some terms, and all of the stuff on this slide is then blown up into a set of use case slides, which I have to switch to here. There was a draft use cases document, and the author is not here, and so this is me presenting on use cases. So part of the purpose of this agenda item is to say, out of the language in the charter, it uses some language that is ambiguous or has been interpreted differently by different people. And so I try to take a taxonomy of use cases that I've heard either in discussion on the list or in the drafts and tried to enumerate them. And then we can decide if all of these are in scope or if we want to scope down and say, well, some of these, yeah, that's not what we meant. We all agree that the following thing is, out of scope. So that's kind of the point of this, is if you have things that says, yeah, you don't think we should address this, let me know, because otherwise the default would be if somebody brings it up and that line is relevant, then somebody's going to say we have to do it. And so the protocol would have to accommodate these use cases in order to be vendor agnostic. Because the point is to have a standard so we don't end up with lots of proprietary solutions. Okay, so let's walk through them. So first, let's go back and say there's a bunch of different entities in the overall ecosystem that have potential requirements that might affect that line number 4 between the entity that has control over what things are allowed in that trusted execution environment and the trusted execution environment itself. So those entities, there's at least 5 of them, and the point is these 5 in general could all be different. There's many cases where some of these might collapse and be the same entity for some combinations of these, but in general there are 5 separate roles that could all be different entities. Okay, so I'm going to walk through those. One slide, I think, on each of these. So there's things that the owner or the administrator of the TE. So if this is an enterprise phone, this would be the enterprise administrator. If this is a TE device like a traffic light, this is whoever manages the traffic lights, right? That type of thing. Okay. You have the trusted application author, so who wrote the code that runs in the TEE. You have the rich application author, which is the thing that's on the outside, okay, which may or may not be the same author as the code that runs on the inside. In many cases, those 2 entities would be the same. In many cases, they might be different. If you have an ecosystem of trusted applications, like payment things, you have different apps that want to make use of a payment component. Okay. Then you have TEE chip vendors, like the guys that actually make that hardware chip that meets those requirements that I mentioned before. Then there are device OEMs, which might take that chip and various other things and assemble it into something that they sell to people. Okay. Again, sometimes the TE chip vendor and the device OEM might be the same, but in general, those are different things, right? And the laptops you're sitting in front of, they're probably different, right? So for example, on mine, right, I have a Lenovo laptop with an Intel chip in it, right? Lenovo and Intel being the TE chip vendor and device OEM, right? On the ones that you have, it's going to be, even on your phones, it's typically different, right? Okay, so when we're talking about people, we want to be clear about which role they are, because sometimes we use terms that convolute roles, and that's where people start talking past each other. So this is my breakdown of the different roles, okay? All right, so I'm going to walk through use cases in all 5 of these here. And so if you say, oh, well, mine is such and such, don't worry, I'll come to the other role here. Okay, so I saw 2 potential use cases for the TE administrator, the guy that actually owns and manages those devices, okay? So the first of the 2 is to say, I want to check the allow list. And so the administrator wants to manage what TAs are allowed in its device. Okay, so for example, since I mentioned that the data is protected, they may have a secure storage area, and that secure storage area may have a limited capacity. And so it may not want to have an infinite number of things with a finite amount of storage. So it may want to say only the following things are authorized to consume that, because I can't fit all of them, right? Here's the ones that I've said are okay. And so in this example, it's the device admin and the TEE that have this relationship that want to negotiate information, not necessarily any relationship with the author for this use case. And so the owner validates the TA and says, this one is okay to go in there and use the storage and use the trusted environment. And so whether you need a line 4 exchange, well, if you're going to pre-provision all that stuff at the same time, then you don't need an exchange necessarily, right? If you carry in a flash drive, you just do it. There are some cases where you would necessarily need that exchange, and that's if your list changes a lot. So we have a list of possible things, and one on that device is kind of flexible, and so you want to do a lookup, and so maybe there's a check and installation time. Yeah, go ahead, Pete.
So Dave Wheeler, and I think it was on the previous slide, actually. Okay. Had a clarification question.
Yep.
Are we missing the TAM for attestation verification?
No. It's a good question, but unless David or somebody else tells me differently, you notice the TAM isn't one of those. The TAM is an agent that is run by one of those entities. And different people's interpretation of TAM matches different ones of those entities. So for some people, the TAM as it exists in those is the same as the device is run by the device or TE admin. For other people, it's run by the trusted application author and so on. So this is why I think the roles are important, because when we say TAM, we got to be precise as to whose TAM are we talking about. And that's why I want to talk about these in this context.
And Dave says, I thought the TAM was independent.
It could be, but the TAM is itself not a role. Okay. That's an architecture thing as opposed to a problem thing. And so if you have a particular opinion on what a TAM means, part of this is to say different people mean different things by TAM, and that's why I'm trying to tease this apart. Okay. But thank you for the relay. And David, feel free to speak up again if you have specific things as we go through that you want the TAM to be. Okay. Okay, so this is a case where at runtime you need to check to see is this thing actually allowed, because I can't be provisioned with the answer ahead of time. Second example of when a TEE admin or the device admin, you might need that exchange or an exchange that matches where line 4 is if it has private data. So the admin says, I have some configuration I want to put in that TEE, and I don't want that data to be visible by somebody that hacks the OS on that device or by anybody else. I want to put some secret data between me and the TEE. I can put it in there and I can use it. So maybe it's my password to my bank or whatever it is, right? I want to configure it. I want to have the following code be private if I want the code to be private, such that the code can't be extracted and analyzed by the attacker. Okay? And so here the purpose of a protocol exchange there would be to get that secret info, or perhaps to get the decryption key for the info that he got encrypted to begin with. Okay? So those are the two use cases that I kind of saw people batting around for ideas for line 4, where the device admin was the guy who wanted it, okay? Or the TE admin, okay? Next case is where you have the trusted application author wants something out of this mechanism. And so very similar to the last one, in this case, maybe the TA author has some information that he wants to keep private. Maybe he has some keys that's part of that particular way that application works that he doesn't even want the device owner to have. It's just between his code here and his code on this particular device that has an extra key. Or maybe it's I want some of that code, maybe the crypto algorithm, whatever it is, to be private because I have some special sauce in this algorithm that I want to encrypt and then send on the code and have them decrypt the code that's just between me and that TEE. Okay. And so there you need the exchange to say, how do I get the configuration, or how do I get the key to decrypt the larger information? Okay, so again, this one is very similar. It's just the entity that wants to protect it is here in this case the application author as opposed to the owner of the device. Okay. Then there was some discussion, at least in one of the documents, about what a rich application author might want to do. Okay, so, well, I want to use the following TA, which might come from another vendor. Okay, I wanted to introduce a dependency on that. And from my reading, yes, that's part of the overall use cases, but I couldn't find a way that this directly affected that line 4 negotiation. It's something that has to keep in mind, and maybe the information passed across there might have to make sure it accommodates this use case, but I didn't think that this is a case because the rich application as author is not one of the entities in that trusted exchange, okay, in any way that I could come up with, okay? So from my reading so far, it looks like this one is out of scope for the protocol except as far as making sure that it actually it's not precluded. Okay. Then there were potential use cases from TEE chip vendors, and this is today I think the way that Intel works with SGX enclaves fits into this category today, which is the TEE chip vendor might have a way to, or might have a need to vet either individual trusted applications or vendors of trusted applications to say, you adhere to the following security principles, the way you write code is appropriate to run on this type of chip. Okay. And so I don't allow arbitrary stuff that's in there because maybe it's not safe to run arbitrary stuff. It's only if you follow the following 5 rules or whatever that it's safe to run things. So they have some vetting process. Okay. So this is a case that says, okay, well, before I install something into there, I want to make sure it's on the OK list. Okay. Because if it's not, then it's dangerous to run on this type of processor for whatever the reason is. Okay. And then there's a similar case for a device OEM. So this isn't the chip vendor. This is the chip vendor just creates chips. And the device OEMs package it together, but the same thing, right? The device OEM was responsible that says, well, I know what's safe to run on these chips and what's not safe, and I'm going to run some vetting process either on code or on individual vendors to say, yes, you're following the rules, you're okay, you can run stuff on these chips the way that you're doing things. Okay. Is that my last one? Yeah, that's the last one. So this is my complete list of all the ones that I came up with and reading all the different threads and the documents and stuff. And with the one exception being the rich application author, all of the other ones, I came up with a reason that says, okay, I understand why somebody would argue that that could affect line 4. And for people to think that there's only one TAM, how you might have an argument about which one of these is the TAM, or which one of these is run by the TAM, right? Is it the device OEM's TAM? Is it the chip vendor's TAM? Is it the TA author's TAM? Or is it the TEE admin's TAM? Or is there some combination of them? That's the architectural question, okay? Because right now the charter does not explicitly constrain us. So either we decide to constrain ourselves, or we say that all of these are valid use cases that have to be accommodated if there's somebody that would use them. And so far, the ones this was come up with by finding either somebody had it in a document or somebody had it in the mailing list or in a presentation. And so there's at least one person that would argue probably for everything that's on here. Okay? And so unless we constrain stuff, this means by default we need something that's generic enough to handle all of these, not introduces a bunch of complexity. And we don't want to arbitrarily take on complexity unless we agree. Okay? Any questions on the use cases now? Part of this is, are there any use cases we should rule out, or should we consider all of these as valid use cases? Yeah, go ahead.
Okay, Suvirdas, I think I agree with you that that rich TA should be, so does that, it should be out of scope?
Yeah.
But does that mean that in your diagram 2A is not allowed?
No. If I go back, the other diagram is in their deck. Sorry, I'd have to switch. But if we can do this from memory, 2A does not go between those entities, right? It's what's in scope for the working group to do as a normative document is line 4.
Okay.
2A, all the other lines are appropriate in the architecture document, which sets the context. The architecture document would not be normative, because it doesn't specify the behavior with the musts and the shoulds and things, right? The line does, and 2A is one of the it motivates one of the use cases.
Okay. So then in the first use case, when you combine device and TE admin, so in that scenario...
What I mean is TE admin, but that's hard for people to parse. It's easier for you to say device admin, but what I really mean is the TE admin, the guy that controls what can run in the TEE of that particular particular device. But maybe that term is too ambiguous, and so I put it here to...
Right. So you didn't mean that the guy who actually manages the device in a normal case.
Right. So the example given, the guy asked at least 2 different people from different organizations, they gave me the same answer for that use case, which is they both used enterprise phone as that example. I don't know why they used that one, but they both gave me that one arbitrarily.
Sure. So so that clarifies. And then do you see a relationship between TE admin and the chip vendor vetting? There could be a scenario where TE admin and the chip vendors could be the same entity, right?
There's many cases where out of that first list, that 2 of those happen to be the same entity. And you're saying other cases where the device admin and the chip vendor are the same entity? Yeah, absolutely. You can take almost any 2 of those and we could come up with some use case, whether it's real or hypothetical. But just about any combination would make sense. Well, that's why it's important, in my opinion, to treat these as separate roles, because when they are combined, we're saying you're doing this in the following role, which is why it makes sense.
This is Hannes. Yep. Dave, I think it was a good idea to sort of recast the use cases from the document that was submitted to the group into those type of different roles. And as Dave said, like initially when the trusted application manager was sort of the intention was to make it sort of an independent box, but of course it has to be ultimately run by someone. And so there are different options, and spelling that out on who could run it and what the implications are with respect to the use case appears to be quite useful. My sense is that we don't want to constrain on who runs it, because that reflects what we initially started with. And I believe even we said that in the charter. Maybe I'm wrong, but at least that was the intention.
The charter is generically worded and does not constrain us.
Yeah, I think that's the right approach. It doesn't, like we do in many other IETF activities, we don't say like...
It constrains us to line 4, but it does not constrain us as to who actually owns the other end of line 4.
Right.
明了派. Just on the use case here, for the role chip vendor, the TA vetting part, I think it doesn't need to be in scope, right? Because we don't need a liability in this work group, say whether a TA is safe, because TA is authored according to TE's trust model. and then you have the more that you trust by the who authored it, and it's TE specific.
Sorry, I didn't understand that. Okay. But I think to the last person's comment, one way to define TAM, there's multiple ways to define TAM. One way to define TAM is to say the TAM is run by, I think it was Hannes, right? Who runs it? You could say, for example, the TAM is, one choice would be the TAM is run by the device admin, and everybody else has to coordinate through him and can pass secrets through him that's already encrypted. It just happens to be the channel that provides that. Another approach that you could take in an architecture is to say you have a whole bunch of TAMs, each of which are run by a trusted application author. Okay, and so that's part of the architecture. Which one is it? Do you have to accommodate both, and so on? So that's an architectural discussion. So all this content here is stuff that I argue would be part of the architecture document, and as the author of the use cases document mentions, the charter says that the architecture document will cover use cases too, right? So.
Yeah. So with this again, I think that Dave, it would be good to add TAM here in this list, because the reason you mentioned that you
Who's
can
the
have
TAM? Is the TAM a sixth entity that is none of these?
No, it could be a combination of any of the things, right?
Can you think of a case where a TAM is run by somebody who is none of these five?
Yeah, it could be a third party.
Okay. So if you think a third-party TAM administrator who is none of these five is a valid use case, then yeah, then if you can write up a sample scenario, well, I should say, do you think that it is practical or is it theoretical?
Actually,
if it's practical, we should accommodate. If it's theoretical,
I have seen that it is actually done that way.
Okay.
Yeah.
So yeah, if there's an actual use case that people would use it that way, then we should add a sixth one that says, okay, third-party TAM provider, sure.
I just want to pause here because I've been monitoring the Etherpad. I don't know if it's just broken for me. So you're just going to type text? Great. Thanks.
Yeah, I know we were having problems with Etherpad yesterday.
And David Wheeler shouts from the Jabber room in response to Subir, yes.
Okay, great.
So I'm going through the use cases in my mind. I'm trying to map at least one of them to the virtualized cloud environments where you might have multiple tenants, have very different requirements for what's trusted, what's not trusted. And you used payments industry as an example. And I can't quite figure out other than the third party one. So it feels like that one either missing or is not descriptive enough to cover that particular situation.
Do you have a suggestion or something you have in mind that you're looking for?
I don't know. I just, like I said, that's a question to the room really more than anything else. Unless I'm missing something and one of those does map to it, then probably use case missing, and I would probably like to add one.
What I got from Subir is there is a sixth entity, which is a third-party guy that does nothing but run the TAM on behalf of one of these other entities, and we should add that as a use case. Got it? I understand that one.
Can you call out your name?
Text authors, welcome.
Sorry, Jim Golovinsky.
I'm not an author of the document.
This is Hannes. Yeah, I think Subir has a point here that this third party and in some sense, so for example, there are use cases where the entity that provides the DE OS, the secure OS, actually also offers at least today, the DAM, and thereby then, in some sense, acts like a third party. But it could be a totally independent third party where the DE chip vendor could also provide that OS and just.
Do you have a term for that? I've heard of a term which there is a term that is a managed security provider, and it could be something that somebody that fills a managed security provider role might do. And so, unless you have a better term, we could use that as a placeholder.
That's okay.
Okay.
Actually, it's about the similar answer like Hannes on that one. So, third-party TAM, right? Use case where it's already managed TAM provider, where multiple enterprise may use the same third-party TAM provider to manage their devices.
Okay.
But it's a mean.
So unless somebody has a better term, let's use the term, at least for this meeting, and maybe in a document until somebody says something better, as managed security provider, because that is a term in the industry for people that you outsource and do your security stuff for you. So Okay, so that is the end of the use cases stuff. And if I remember right, Hannes is up next to talk about architecture stuff. So Hannes, you're up.
You actually burned the time there. But you have any questions?
Oh. So we'll talk a little bit about the architecture. You've seen actually most of this already with what Dave had been talking about, just in a different representation in some sense. We haven't really settled on this term yet, so sometimes I use the term developer, but we've also used the service provider notation in documents, but maybe those two are not the best possible terms, and so we'll have to figure out on what the terminology is for some of the boxes. Dave already walked through some of those questions that relate to the entities that he had, or the different roles, the different parties that are played here, and I definitely think we have to document them. So currently there's, as mentioned, there's no separate architecture document, but it's somehow folded into the OTRP document, so that has to be extracted and expanded to actually get to the state where we really want it to be. I'm skipping those questions into you, Dave. You already talked through some of that. This one is, I believe, quite an important picture, and I would like to spend a little bit of time on this one and walk you through that. So we have a couple of different players here, or entities. On one hand, we have sort of assumed the public key infrastructure, sort of like a asymmetric crypto model. So there was no intention to use symmetric keys for this type of architecture. On the software side, the flow starts with sort of the application provider or developer service provider, and then the trusted application gets pushed over to the DAM, as Dave had shown you on the different APIs. So this one doesn't show the distribution of the regular rich application. So, but this is now the interface that we have been talking about, illustrated in red here. What you will notice here that there is an agent, simply because the DE itself doesn't have the network connectivity. It doesn't act on its own typically, so it has to sort of interface with the outside world using some form of code that is written there. And in the walkthrough that they provided, this was the rich application that was downloaded, in that case, dynamically and then invoked. And that's sort of the agent that just passes that information along, but it uses an API here to switch between sort of like the normal world, or the rich execution context to the secure world. And in case of a global platform, that's an API. Other DEs use different APIs, but there's some mechanisms to transition from one environment to the other one. And then in the end, there's also another component ultimately there. That's the sort of like, if you will, a client-side component that then runs the protocol in question to get the code, the trusted application code here, and then verify, do the crypto processing, and also install the code as necessary. So that's, and this is, there are these hardware enforcement techniques that were called out earlier in context of the problem statement discussion. So this is what we are really focusing on, this interaction that goes through, starts with the DAM and goes through this agent on the sort of rich execution context into the DE.
I think the important thing to note out of this slide, if you haven't already looked at the document, is that the security session follows the red lines and goes end to end between the TEE and the TAM, and the agent has no visibility into the keys, right? So the agent is just providing connectivity, but doesn't terminate like the SSL session. It may terminate the equivalent of the TCP session. The SSL goes straight through it. If you're using SSL, that's how to think about it. The security association goes between the TE and the TAM, and the agent's job is like the TCP/IP stack or whatever your communication stack is. Yeah.
Yeah. So this is sort of the regular Internet protocol, And the dotted lines here, if you look at the legend, that's sort of the exchange of certificates and keys prior to the exchange. And that's partially what Dave had been illustrating with the different use cases that we've seen earlier with what the different roles are supposed to do. Okay. That's maybe a little bit an eye chart, but I posted this entity relationship diagram to the mailing list in an attempt to clarify some of the entities. And maybe based on Dave's presentation, we would have to expand those relationships a little bit. But in a nutshell, the relationships are as follows. So we assumed that there's only one DE on a device. That's one observation from that figure. That was sort of a working assumption also in terms of the protocol and what information is carried in a protocol. Otherwise, if you have multiple DEs, you have to have some way of identifying which DE you want to talk to. We also said that there may be multiple TAMs for a given device with a DE. So that DE is managed by one or more than one TAM. It depends on the use case. Maybe it depends even on as much as having one TAM for a single trusted application running on that DE. Could be possible. Then, and I will talk a little bit more about this security domain concept later. So I will skip that. But in any case, there's a trusted application that sort of resides in this security domain, and there will obviously be multiple trusted applications potentially running on that DE. And these applications are developed by this application developer or service provider or whatever you call it. And a single provider may actually have developed multiple applications. Okay. So that's the question maybe to the group here is the limitation or restriction of having a single DE for a device, is that a good starting point or not? Subia.
Yeah, so Hannes, I do support that one DE, right? But in the previous slide, I have a question for you. Mm-hmm. Is it always necessary that all the use cases what Dave mentioned needs to interact through this a piece of software with the app and also the agent, or there will be other ways to reach to DE?
Are there other ways to reach a DE without using an agent?
Without using these two, whether it's app or agent.
This is specifically, you're talking to something in the TEE that's used for provisioning.
Correct, exactly. For
There's
example,
other things that you can talk to in a TE besides the provisioning service. You can talk to an individual TA once it's running, right?
Right. Say, for example, I can think of device OEM, right? So device OEM, is it necessary for them to go through that path, or they will have another path to interact?
For what purpose?
So
for
provisioning or
for provisioning of a TA?
Yeah, it means I can add. So first one, yeah, you raised two cases. First one, get TE, how to interact with TE from rich app, from normal world. You need something, right? TE specific. So we have this is called the OTIP agent. It's a TE specific. It was expect the TE provider provide it. And then for the application pre-bundle case, like OEM case, you may have TA pre-installed in device. But then when you talk with the TAM, for configuration data or called personalization data, you need a way to interact with TE. So rich app typically will rely on some agent which knows how to talk with TE. So
that's fair enough. But I understand for the TAM, this is the path it should interact, right? But I was just referring that all the use cases, what is listed, in that case, TAM may not be required, for one of the use cases.
So I think this is the path that anything that uses the protocol that this working group does would follow this path. I mentioned there's a bunch of proprietary solutions out there, and the proprietary solutions may not follow this. They do whatever proprietary solutions do. If you're going to use the standard, this is the path that it would use.
Yeah, that's fine. I just wanted to verify that this is the path what everyone has to follow.
Yeah. So practically speaking, so for example, if you take a Linux sort of normal world OS implementation or rich execution environment, then the agent, for example, that would be a piece of software running in a kernel that interfaces with sort of the DE, and there has to be some application code as mentioned that basically talks using internet protocols to the DAM, to the server using HTTP or whatever, and these two sort of the kernel module needs to provide an API which is sort of indicated using this another arrow here, the black arrow, and so that this client code then has the possibility to talk to the kernel, which then itself interacts with the DE. So that's one sort of practical implementation choice that many have used today. Could you merge those two together? You could. Would it be useful? Maybe in some contexts, like if I think more about an IoT environment, maybe there sort of this the separation between OS and what the applications are maybe a little tighter. So I wouldn't exclude that, but conceptually, it's still these two different roles.
Okay, David Wheeler, you're up next.
Hi, can you guys hear me?
David?
Can you hear me?
Not getting anything. I don't know if we lost you, David. Checking on
Yeah.
Jabber. Okay. Relay to Pete.
Relay.
We're not getting anything. So I'm going to mute. Okay. Go ahead, Pete.
David says, my mic isn't working.
Okay.
Yeah.
Okay.
Okay, that's okay. So to continue.
Yep.
The
Actually, I wanted to make a comment as an individual. So rather than rocking down there, pretend that I'm down there. This is Dave Saylor. I don't know why that we actually need to have a concept of device. This is the last question that you were asking. Is it okay to have a one TE per device? I don't think we care about the device. We only care about the TEE. So for example, if the TEE has an agent and the agent makes an outbound connection to a TAM, whether there exists multiple agents, each with its own TE on the same device, you don't really care. The TAM can't tell. It's just getting a connection from each agent that talks to a TEE. So I think the device is not actually central in the architecture. I mean, you can delete the label device and have exactly the same protocol and the same meaning, I think. Correct me if I'm wrong.
I just wanted to relay from David. He says, there must be multiple TEEs, though. The device represents the OEM relationship to the TEE.
Mm-hmm.
Yeah, I was actually going to reinforce that
nods
as well.
I'm just repeating back to David so we can hear since he can't see the room. There were several nods when Pete was reading that. So go ahead.
Yeah. So I was gonna reinforce that as well. That there certainly can be multiple TEs running simultaneously. One or more TAMs, I think that's fine. But the one-to-one relationship there between the device and the TEE is something we should probably reevaluate, because there certainly are use cases. I mean, if you think of the TPM as being one, right? Then anything else that you start adding, you automatically start having multiple TEEs in the space.
Yep. Okay.
Yeah.
That's what I heard or saw from multiple people.
Yeah. Of course, there are devices with multiple TEs. The question is whether that's something we should start with initially, because of course it adds some complexity. But I hear you saying that you want to support that rather than saying, of course, theoretically or even practically those exist.
Yeah,
Practic. Yeah.
On that one, so we started with one TEE, because for like several billions of devices today, they all have one TEE, like phones, right? Phones, set-top boxes. But now, say, new use case multiple TEE. As long as the challenge, as long as we don't need to look up TEE, which TEE I talk to, like the agent, then it's okay, it's equivalent. One TEE and multiple TEE do not matter there. But once I need to handle the device have multiple TEE, which TEE I need to talk, I need to enumerate, and that logging protocol in this charter, and then that's add the complexity. But David mentioned, and he said, okay, as long as the app knows which TEE talks to, then it's all part. It doesn't matter in this case.
Mm-hmm.
Somebody behind you.
Max is behind you. No.
Max Pritikin. I see on the diagram and in the conversation we're saying that the relation between the Dyson and the TEE doesn't matter as much and in fact could just be abstracted out. But it occurs to me in thinking that through, it relegates the device level and that being the app and the proxy or whatever you called it on the previous slide. It relegates them to having no information about what's going on inside of the TE. And then it makes me wonder about what we really end up here is the TAM through to the TEE to install these trusted applications that the device doesn't know about. And that makes me start to worry, and I couldn't find anything in the document that addressed that. So it's tangential to the conversation, but I think is related.
So Max, you would say like you would leave the device in there because it's still.
I think it's important for us to consider the device's relationship with this protocol flow and what it needs to know about monitoring or not know, and have an articulated statement about that. Even if the statement is the device doesn't know about this and can't tell whether there's applications being installed or not installed or what's going on with it, because that has significant repercussions in the security consideration section. So I wouldn't just abstract it out and say it doesn't affect it. We can ignore it.
Okay.
Okay, so we're just conferring as chairs. So I gave a personal opinion before that. I didn't think the word device was necessary in here, but I haven't seen consensus for that. Instead, what I've heard, I think, as chair, is that we've heard rough consensus that we do need to allow for multiple TEEs per device. If you have objections to that as a rough consensus, but that's what we're hearing as consensus. Let me know if you misheard that. But for the note taker, that was rough consensus.
Yep.
Okay. Carry on.
Mm-hmm. So the security domain concept is something where there's another isolation concept within the TEE provided by the operating system running inside the TEE. And the idea is that as you load trusted applications from the same sort of developer or the same vendor, they can share or can reside inside the same security domain. And thereby they can exchange information while trusted applications sitting within different security domains cannot exchange information. That's sort of like the idea of the security domain concept. And currently the way it is, the mechanism is assumed is that there are potentially multiple security domains in there where a single security domain can have multiple trusted applications. And that's what you what you can see in this relationship diagram. So you have the trusted app may belong to one or multiple security domains, and a single security domain hosts one or more apps.
I think we need to define what do you mean by security domain, right? So for example, is a security domain a set of data that is used to provision the one or more applications? Is the security domain the data or what? What is a security domain?
Yeah. So I'm personally struggling with the concept a little bit because it has its origin coming from the smart card industry, where probably the separation between these applets running on those smart cards was a little bit different at that time. And of course, technology changed a little bit. So the way how I understand is that you have a way to, for different trusted applications within the same security domain, to be able to access the same data.
Okay.
So it's a
data container.
It's a data container.
Yes, I mean, yeah, I agree. So just a security domain also is a TEE implementation specific, right? So I would say realize the reality today, several billion devices and several of the major TEs are all implement security domain, right? Regardless of smart card, old one, new, but it's an existing reality there. I think this concept is there. But for new TEs, right, they say they don't know a security domain, but if they enclave others, it conceptually similar. It's isolation. I think I would say more use as a concept. So it's a TE specific implementation. I'll leave it that way.
Yes, we're having the architectural discussion, and I see Andrew, you're going to be in queue right after me. I don't know, are you in queue up here? Or,
yes.
Okay, you're going to, so me, then you, then Andrew. Okay, when I walked through the requirements of a TE before, I said that the third requirement was that the data inside the TE couldn't be accessed by code that's outside that. Okay, this is actually a refinement of that and says actually it's stronger than that, because if you have two applications that are running inside the TEE, this means they can't access each other's data either. So they're protected not only from the code that's outside, but also from other applications that are inside. Okay, which is a stronger statement. Okay, and so this is not a chair hat. Sorry, thank you. Yes. Yeah. Right.
Not as a chair.
This is me and Q in front of, I can't remember your name, and in front of Andrew. Yeah. So I think what you're saying is that the security domain is a refinement of that that says, okay, if a TEE supports this extra characteristic, which wasn't one of the three requirements for being called a TEE, but most of the ones today actually do have that property that you're talking about, this notion of isolation between two different trusted applications. Right? SGX has that, and TrustZone has it, and so on. So you can have that level of protection too. And so if you have that level of protection that says you're protected from other TAs, then this is what we're talking about here. And then you can ask your question. Okay, so that's the end of me. You're next, then Andrew, then Eric.
Rashmi Dakavain here. I'm looking at the TE from the 5G slicing in wireless domain perspective. And from my perspective, security domain can actually get involved in when you're talking about different slices. So different slices basically represent different security engine and security domain, in which the requirements for each slice will be different. They could be provided by different service providers, or they could be providing different quality of service and type of service, depending on the slice that the telephone is, or the phone specifically will connect to. So this is, to me, the security domain that will all go under the same TE, but they all represent different slices in the network, basically. Right?
Andrew, you're next.
Can't hear you, Andrew.
Can people hear me?
Yep.
There
Yes,
you
we
go.
can hear you. Go ahead.
I wanted to point out about the security domains. In OTRP, there's no data sharing for TAs inside security domains. The security domain is just a relationship with a service provider outside of the TE.
But it doesn't. It doesn't. That doesn't explain what it protects against, what it isolates specifically, or what it. In this case, if you have multiple trusted applications running within the same security domain, it seems to relax that isolation. But it doesn't. Your statement didn't explain on what, with respect to what resource.
Well, each trusted app can only see its own data that's associated with it. I'm not convinced there's any data sharing mechanism in place for us to be able to control here.
Well, it sounds a little bit like we have to drill a little bit deeper into the security domain concept,
Yes.
because apparently we have a different understanding on what it really does today. I think it's a good item for homework.
Okay, let's go to Eric.
Eric, not Mark. Yes, I understand isolating separate trusted applications from each other. Basically, security domain and trusted application are one-to-one. Mm-hmm. But you showed a picture that had a many-to-many relationship, which I don't understand the use case for, and it seems very complex to manage. And who would manage those relationships? Who says that these guys are supposed to share things, right? It sounds like a big opportunity for misconfiguration, whoever is in control of that configuration.
So, Hannes, would you like to ask the last question on your slide then?
Yeah.
That was a great segue.
Well, but I believe to have sort of a good answer, we would really have to understand the security domain concept really clearly. But the question that was also discussed on the mailing list that is up for an answer is: should there be a restriction of having a one-to-one relationship between the security domain and the trusted applications? So in that sense, a single trusted application resides within a single security domain rather than having multiple trusted applications residing within a security domain. And I hear you, Eric, basically arguing for the one-to-one relationship.
But
I
that's
heard
what-
Eric
yeah.
arguing
Yes.
for yes. The answer should be yes.
It is mean.
Or at
So-
least you did not understand why an answer should be no. Is probably a fair characterization of what you said. Yeah.
So the use case was like what do we want to limit only one, right? That means you have one domain per app. Or initially, so we have, say, as Andy mentioned on the call, one domain can be assigned to one service provider, which may have multiple applications, right? For their multiple trust applications, they may have some interaction, right? It's okay within that same domain. So we don't have to limit to it. It's a little bit more option there versus a restriction.
Right. So even if the answer is 1-to-1, this is Dave, even if the answer is 1-to-1, it doesn't preclude the ability for different TAs to communicate. In the protocol document right now, it says you can have an API that allows, a TA exposes to allow API TAs and other application domains or areas to talk to it, right? It talks about that right now. So it doesn't preclude communication. What it affects, and here I'm just going to summarize what I think Eric was saying, is that if the answer is multiple, now the way that you provision it, you say, here's a set of data that applies to multiple TAs, as opposed to a way of provisioning stuff that goes to a single TA. We understand how to provision stuff. At least we think we understand more how to provision stuff for a single TA in this exchange. It's a lot more complex to say, and we want to provision stuff that applies to a collection of TAs, and we don't understand if that complexity is actually warranted. Because it does, if you don't do that, then it doesn't preclude it, is what my point was.
Data.
So Eric can come back up if I misinterpreted
Okay.
what he said. So he's coming back up to the mic. So
Yeah, adding some more color, right? If you say that, well, I'm going to have somebody that expresses policies about these collections, right? You have to be able to securely name what's in those things. So what are the names of those things? Because when I have a regular app that refers to trusted app, that's a relatively simple naming scheme, right? But there's lots of things and once you figure that out, right? Saying that, well, when I refer to app B, it really is B and not B prime, right? Then you still have to figure out who controls that policy, right? And particularly when it's many to many, right? As opposed to many to one, when it's one direction or the other. But the use case for one to many and many to one would be good to understand those in a fair bit more detail before concluding that we actually need many to many, which is the worst case.
yeah, because you mentioned, Ming, in the global platform case, you think that they had a one-to-many relationship. I think I see two Intel people near the front of the room. My understanding of the Intel one is it's one-to-one in the Intel case. Every enclave has its own storage that's not shared with any other. And I see the Intel people nodding. So yes.
Intel is my understanding also enclave you can have even OS running there, the big app, or that's a name. Within that you have other apps. So I don't know that you really.
I was just trying to get
limit
a vendor agnostic view of the
Yeah.
plethora of answers here. So.
So I just go back. So for Intel, so you have GSX, right? Inside the one enclave, you have you can even run OS as app there, right? Within that OS, you can have other apps running. So do you consider that one app or multiple apps? I consider it more. Yes. Yes. You can run multiple, right?
What's the definition of an app? You're just talking
Yeah.
whether this is
Exactly.
10 kilobytes or 10 megabytes big. Is that, or is there some distinction between app as opposed to OS that's relevant?
To me, it's more like a separate signed binary, right? So like this app, it's a separate signed. I'd say but that's more T specific. Like a global platform has a T definition.
Okay, I think we're getting a little too
Yeah.
deep in the details here. So
Can I just respond quickly to that?
you'll be the last one to
Yes.
comment.
Okay. All right. So the enclave is defined. So you can have it be arbitrary, right? So in some sections, it might just be a section of code that is the enclave, and in other sections, although I've never done this, theoretically, you can have a very large enclave. I don't know why you would want to do that, but you certainly could. But in general, you're building these trusted enclaves supported by the hardware root of trust that you can define from the source. So it's very flexible, and that's why you can have multiple trusted execution environments running simultaneously.
Dang. Okay, absolute last one. We need to move on.
Yeah, David says in the chat room, there is not an ability to run an OS inside SGX.
Yep. Okay.
Okay,
Okay,
let's move on.
And okay, I have one more slide. So there are As mentioned beforehand, we're talking about the PKI infrastructure, so there are several keys flying around. You've seen the CA already with the keys, signing different other keys. But then each of these entities, the application developer, as well as or service provider, the TAM entity TE are assumed to have keys, and they have used for different purposes, which I wanted to highlight in this slide. So when you read through the documentation, it feels a little bit complicated because there are different keys in play here, and those are the most important ones. So the TE uses a key that is provisioned to it for attestation. There is a separate sort of set of or a separate pair of keys that is used by the TAM because the TAM has to secure the messaging as well. So those are, in the case of OTRP, signs these JSON structures. And then with sort of Jose. And then there's, of course, also the developer service provider, and he needs to have keys as well because he needs to sign the trusted applications.
Yeah, okay, yep.
And that was
Ming, you're up. Okay. So all of this has been discussion on the architecture for which we don't have a document. There's just elements scattered around in various places. And so all of this will inform the creation of a hopefully well-written architecture document in the future, but we don't have one at the moment. So. Right. So now we're moving to the discussion on the protocol or the solution document that is informed by all the stuff we just went through. So let me find the right deck here. That one. Okay.
So continue from the architecture description. So this is a draft we submitted about a year ago, and this version 06 has several versions. These are all the co-authors listed here from different companies and have been a lot of time work. I will provide some update, what modified, also talk about a little bit quick introduction. In a top high level, to realize the use case and the architecture, the document contains, right, first part actually contains the architecture description. They have the protocol part in one document. So, and in this protocol, what we choose, we use an asymmetric key and a certificate to establish mutual trust. Okay, this is a contrast of a symmetric key, use asymmetric key in that aspect. And the device side will have a certificate key pair, TM or certificate key pair, SP or app developer. So that's we just align on terminology here. They will also have a certificate on a private key pair to sign the trusted application. And we generally need a OTRP agent which runs in a normal world, in a rich world, to relay the message, so as David Hannes mentioned earlier. So, and for now, we start with a JSON message format. This is a message protocol, okay, message protocol. So to establish trust.
Ming, I'm just going to clarify. Yeah. So for this presentation, what Ming is presenting as part of the solution is what's being implemented today vis-a-vis the design choices. And so we'll have a discussion later as to the path forward for what we want to include here in TEEP.
All right, so if you have questions about what's in the document now, ask them now. But if you have questions about what it should be, wait until Nancy's presentation. She'll talk about what the working group wants to do. What Ming is talking about is what's in the individual submission right now.
Right. So I'd like a feedback. I would defer that one to the chair's question.
Forward questions, defer those till after Nancy.
Yeah. Just hold on your question. This one just talk about now what in the spec, what in the draft document. Yeah. And the draft is capable to support different transport protocol. Okay, I mentioned it, but default now we specify use HTTP as default one to start with. Here's a 7 top operations and messages we defined to support the full life cycle of device management. Right. The first one is get the device state. So TM will send a message to current device. What's the TS installed? What's the SDC created? So get the device data back. So that having information on that response flow also gets what the TE's certificate information. So in future, all the transactions will be encrypted, right? All the message can be encrypted when we send to TE to achieve the end-to-end security. Yeah? And applicators that status what's available in the device itself, including capability of the device. Okay, capability in that device. That's part of the get device state. Once you get capability, what argument support, including this kind of algorithm agility, all this inside that one is a little bit more detailed on that one. Just in high level, it's a core, what capability, what you have. Then it's good to create the SD. So secure domain is a core concept here. It's used for isolation. Okay? So we have the create a secure domain, and then you can install the trust application inside that secure domain. So when you create a secure domain, then you can update while you need to manage the life cycle. You need to update secure domain later, and you can delete secure domain, right? Free up a resource if that application not needed anymore. So you have the secure domain management, 3 messages there. And once the secure domain ready, then you can install the trusted application. As you install trusted application, gets a message, which will include the binary data of the application. Optionally, it can be pre-installed. And the configuration data, personalized data about that trust application. Well, of course, you have life cycle. Once the application is installed, you need to be able to update it. We have new revision, right? New version you need to update or remove that application. So that's the top level, 7 messages we define to support the life cycle. Okay? The main ones are built mutual trust. Device trust TM, TM trust device, and then you can carry out these transactions. Then briefly mention about OTRP agent. This one's you need, as a Hannes mentioned, architecture. T itself does not have capability to talk with in network layer, right? You need someone in a rich world. So rich world has OTRP agent. Okay. OTRP agent just relay the message between TTSM. As also David mentioned, it does not interpret the message. It's a black box. It just relay it. Actually, message is encrypted. Messages are encrypted between T and TSM. It cannot see it. T will encrypt the message with TSM public key. TSM will encrypt data with T's public key. It's a mutually encrypted. So that it's a black box to relay for the network support. Okay, that's a pretty straightforward one. Just to mention here briefly, it may have a little bit in case it can talk with T, cannot talk network. You have some basic generic error, right? That's one. We need to handle error code, more about error code that TSM need to handle. A TM, that is diagram TM. Yeah. So it has 2 functions. The main one, first one you can see is a process OTRP message. It's an abstract API that the OTRP in general should support. The input is just the message you receive from TM. Then it's a TE specific and knows how to talk with TE. TE vendors will provide that. And TE process that message, return just the OTRP message back, and it relay it back to TM. So that's really the generic job. We also provide another convenience API, get the TA information, so that the rich app or client application, rich world can query trusted application locally. It doesn't have to always go to TM, make a network trip to query trusted application. It can do local query. Okay, local query. The response can be verified. Okay, we have schema there that message be signed by TE, but give it to this rich app, which belong to same app developer or different. They can verify it's from TE. Okay. So give a high level quick flow how this overall work. The workflow started say normal app. Oops, sorry. The client application start trigger that request TM. So assume this is an empty device. Okay, you have a blank device. In the beginning, you don't have TA app yet. Typical case where ask TAM. TAM what does is ask a device. So what do you have? Do you have that TA already, or it's what version you have? What capability you have? It's send the get device state message through OTP agent to the TE, and the TE device will verify the TAM is the one who authorized the query. I trust that the TAM. After that one, it will collect local SDTA information and sign and encrypt response sent back to the TAM. TAM now has the information about that device. It can decrypt user public key. And the next one, once it's verified, it will send the next one secret domain command as a message to the TE. The TE now is create a secret domain based on name and based on whether trusted TAM, also based on whether the device state has changed or not, right? Because this has it's a mutual back and forth round trips. So we use a device state also to maintain that atomic consistency. If the sensor change, it may say, okay, this domain has been created by different one. If the name has been taken up. So after secret domain is created, then just send a response back again, the current device state every time to collect current state after domain created and new information back to the TAM. This device state is optional. It's a negotiation, right? It's an optional response. So next step, the TAM will say, now you're ready to install the trusted application. It sends out the binary data of the TA and any personalization data or so-called configuration data for that TA in encrypted format to the TE device. And the TE in the device will go to verify the trust of TAM, decrypt the TA and the personalized data, and will be installed that TA in the device. So that's the main basic flow. There are other variations. This is the main flow, give an idea how they work.
Max Pritikin, I have a clarification question. I've been confused by the draft and now your presentation as to the distinction or relation of the TSM and the TAM.
They're synonyms.
TAM.
They are synonyms.
Earlier we called TSM in older terminology, later changed to TAM. Yes.
That explains a lot because I was.
TSM is the older term
Thank
that was changed to TAM.
Thank you.
Yeah. Okay, I'll move on. So for now, we start with JSON message because in the beginning we deal with a lot cell phones, set-top boxes, several billion devices, such ones each year. They're very capable, right? JSON message. We use that one which is relatively concise, and also we can use a standard JSON sign-in, encryption, all those standard from IFC. We don't need to record them. So we choose use a JSON message as the as a message exchange and a message format. The message follows such a convention. So it's a operation name and request response. And to be signed, like the message is always signed and encrypted. Okay, encrypted and signed. Okay, encrypted sign, encrypted sign. Right. Because only first one is not encrypted. It doesn't know. After that, once it knows each other's public key, it's always encrypted. Always encrypted, end-to-end security. Yeah. So this is just standard JSON message as a signed one. So the payload itself contains real encrypted data. That to be signed piece, it's encrypted internally. All this internally structured, just use IFC JSON signing encryption method. So that's all. So I briefly touch on the change from prior versions. First one we added, based on the feedback in the mailing list, TP mailing list, we added one transport support, HTTP, added to HTTP will be. That one, you know, that transport is really handled by OTIP agent or rich application to the TA, right? It's not TE, because TE does not have a capability. It's really in the rich application level. So HTTPS is to pick up default for now. Okay, there's other chair have more questions whether we need support others. If need, we can. Okay, and we made a few small schema changes. Once you get device state request from version, we changed because certificate you need always support the revocation status check. We require the OCSP stapling data in the passage itself. And the certificate may have multiple layers of CS, right? CS, intermediate CS. So then you may have multiple OCSP data. So we put it into array. Earlier is 2 elements. We now make it array. Also supported for argument negotiation, right? Argument agility. So it was earlier as comma separated, now we make it just a JSON array. So to make it based on the feedback from the mailing list and from actually David's comments. We use JSON Boolean value instead of string true or false, make it just directly use that one. That's actually global platform was from earlier several changes. Use time, the comment earlier, use time consistently. So it was in TSM, I changed entirely time in the latest version draft to make. So what that implies that earlier we had TSM ID, now all change TM ID. So name field change, it's a considered schema change, by the way, no. But I think for all this, we are, remember charter or the mailing list is not a hard requirement, but we try to keep consistent with other standard bodies like global platform. We work with the editor community with them, so we will just collaborate, so they will make the similar change. We consider this the right thing to do. Yeah. And based on the feedback, the OTIP agent was earlier a little bit more API, a little bit more interface language specific. We make the abstract API, follow the IFC convention. There's also the error code. Earlier we have you see this error code that TEE signed and returned, versus those on OTIP agent. For example, when it failed to reach TEE, it didn't respond some back to time. So now this we have used a little bit different prefix to differentiate those, make it clearer, There's a few other editorial changes. Those are just minor. So these are the main changes from a latest version. The main one's about transport support, I would say. Transport support. And for the transport, I just gave a little bit of color here. This is my last slide. So I just want to emphasize that TE generally doesn't have network capability. It's up to the rich application, right? A rich application do that part, and rich application use a device which has TE, like we talk about TE here, different flavor TEs, right, in this room. You know, it's a lot of have quite a capability to do HTTPS in a rich world. At least the phones is always trust zone or STX, right? A lot of billions devices. There's a capability there. There may be other IoT devices which may not, but that's the question. Say, can we just say, are we fine to start with current choice, just HTTPS first? Or we need like a co-app, right? More for the constrained devices, but that's a leave to as a transition to chairs for the follow-up question. Say what's good feedback so that we can revise the spec, because this one just a new transport protocol support. We just add one into the spec, so that's capable to do that. So, yeah, so that's my draft update here.
Okay. Thank you.
Thanks, Ming. So while we're switching, boy, I can't talk. Blue sheets. Has everybody gotten a chance to sign the blue sheets? There should be 2 floating around, so make sure you sign for them. Where's the second one? There's one over there. Would you mind bringing that one back up front? Yeah. Okay. So thanks, Ming. That was a good segue for the draft. No, you don't need to be here. Unless you want to.
Yeah. Do you want to stand up or just sit here? Okay, so we're at point 7 on the agenda now, which is architectural questions for the working group, and wrap up, and Nancy's going to lead these 2. So.
Yeah, so for the path forward is we're going to
go to advance past the other slides. So, yeah, back one.
Okay.
Oh, yeah, you're right. You're good. Go on.
Yeah. Okay, so getting better guidance, beginning with the architecture and then following up with a solution. Ming presented to you the base draft that is really the considerations as they've implemented today. So with respect to the message format today, they've implemented things in JSON. And this was some of the feedback that we took as we were forming the BOF. And the questions that were raised there was, does it have to be JSON, especially given the different use cases? So the question that I want to discuss here and get working group guidance is, should there be only one message format, or should we allow for several of them? So Json is already in the specification. Should we consider others? So wanted to open that for discussion. Or is everybody in a food
I
coma?
mean, the Boston on the list, there were some arguments for CBOR, and given that there's a one-to-one translation defined between JSON and CBOR, that would not be difficult should we choose to do that. But this is where we wanted to ask that question.
So I wanted to leave it open-ended, but is anybody awake?
Yes, people are awake. Okay.
Or apathy.
Yeah.
Yeah.
This is Hannes. Yeah. So the initial format, the JSON with Jose, was chosen because one of the initial use cases was sort of more in this web application domain, app developer, classical mobile phone app developer case, where JSON is obviously more popular. And if you have, if you want to serve that community, then that's a good choice. Then later on, people brought up some IoT use cases, and that's there. It's a little tricky to say like what is the best choice there, since we sort of the use. Of course, there are IoT devices that use trust zone, even though, but the big question is how are they connected, and does the use of, let's say, CBOR make a huge difference? So there was this document by Alibaba that argued for the use of CBOR. And this is something I still haven't wrapped my head around, whether that's a good idea to have two formats, or on how that actually would look like, because it's not just a different serialization, but there's also the COST mechanism which we would use, which makes introduces some changes. So that would that be a separate document, or how would that work?
This is a question about what the working group does as work, not about document organization.
Right.
So separate question.
Yeah, I mean, so the reason why this is part of the architecture is, if we're going to consider more than one format, the architecture as well as the protocol needs to be able to allow for that, and perhaps a negotiation. So we need to get that high level first.
Yeah, it's worth noting that there is an individual submission that does propose a CBOR serialization of the JSON stuff in a separate internet draft right now. But the question is not about adopting stuff. It's about, do we consider that we need to do two formats, or at least two serializations of the same information?
Yeah. The reason why I'm struggling with is because we also said during the chartering process that we want to have a fairly good alignment with the suit working group, and there. As you know, like the direction went into CBOR COSI with the format, and in some sense, one could argue that one possible alignment is to have the application developer sort of acting as the author who creates the manifest, signs it, and that provides the metadata, which currently the OTRP doesn't actually define anything on how the specific firmware image looks like. So that could potentially be an alignment.
Suit working group chair on for just a second here. Suit has chosen, at least tentatively chosen, CBOR for the IoT class devices, because Suit is constrained to the IoT scenarios, right? And so there, the assumption in IoT is that you will have a CBOR parser, and that you might not have a JSON parser in your device.
Yeah.
Okay, I don't want to get too far behind in comments here. Jeremy O'Donohue, who was having trouble getting into Jabber, so he personally IM'd me. He says, main problem is that I'm not sure if JSON currently defined is translatable to CBOR. Any response, or I'll just go on with comments if there are none.
I think many people believe that there is, and there are tools that do algorithmic transforms between the two. I see a couple head wrinkles in response to that in the algorithm. So at least it is a common belief, correct or incorrect, that they are transformable algorithmically.
I think there was at least one tool, so we'll have to dig it out.
Yeah, I know of at least two tools. In fact, one was actually in use at the Suit table at the hackathon.
Dave Crocker initially says, alternatives create complexity and breed errors. What's the compelling reason not to have a single canonical format over the wire?
That I think we've heard the answer to, which I'm starting to form a personal opinion as to what I think we should do. But I think the reason is if the IoT devices will only be capable of using CBOR, and I put the if in there because that's a potential direction that things are heading. And if global platform devices are only capable, or web-like devices are only capable of using JSON, then the rationale would be to get the same protocol to be usable by both use cases.
And David Wheeler, I think in part to reply to Dave Crocker, says a binary representation is required, from my opinion, for IoT.
Okay. All right.
And then Dave Crocker follows up with, it's probably worth distinguishing having two core formats versus having a single core format with some standards for transforming into an additional form.
Correct. And Suit was doing the same thing with the manifest format that says that there was in the Suit charter, right, there's and I see David Waltermeyer, my co-chair, is right here in the front row, that there's an information model that says, here's the stuff that gets expressed, and there might be more than one way of expressing it on the wire, like in CBOR versus in something else, right? But that's all exactly the same information, just two different ways of serializing it. So that's something we could do because that's what we did in Suit. Okay.
Right.
Brett Jordan. In general, I am against having multiple forms of serialization. We should pick one. I don't care which, CBOR, Cap and Proto, Protobuf, JSON, whatever. When you have multiple serialization formats, you increase implementation cost and you decrease interoperability. And then we have to figure out, how do we do some sort of negotiation protocol so people can figure out which version you're using? And just the overall complexity increases. And I think the goal initially with a lot of these standards is to get adoption and get these things actually being used. And the bigger the step, that the more complex it is to implement, the less chance that it's going to get implemented.
So again,
I don't know how to make that be actionable yet, because if you're going to pick one, you'd have to say which one you'd pick, and that would entail the problems for one of those two groups.
So maybe defer this one.
Yeah, because and I saw somebody else said this on the list, which I'm starting to agree with, which was the example was if you have two formats, let's say that they were JSON and CBOR and serializations, that both would be mandatory to implement for the TAM, and that the agent who would pick either of them. And that depends on the use case, but the TAM, you'd have two mandatory to implement on one side and pick either one on the other side. And that's one way of doing a mandatory to implement solution.
Okay, so I guess as the chair, we should just continue this, the discussion. I think the reason why this was brought on, especially during the BOF and the chartering, is when we went through the use cases and the applications, is where it arose of web applications on some devices, but then IoT constrained devices, considering CBOR, and now looking at what Suit is doing and embracing CBOR for IoT. I think even in our charter, we said we would try and get alignment with Suit as well. So
it says we'll try to be aligned with Suit and with Global Platform and with the TCG.
Right.
And it turns out that you might not have a common solution between all three of those.
Yep.
A common serialization format.
So we'll just take one more and then we'll move on to the next one, but we'll continue the discussion.
Yeah, Dave Crocker wanted to clarify. Dave Thaler's interpretation of what I said is different than what I mean. Okay. I'm suggesting a single common format, but separate effort to gateway to alternative formats. The difference is where the alternatives occur, and yes, when everything happens within a constrained environment, they might use the alternative format only.
Okay. Point well taken. Okay, so this one will be continued discussion on the list. The second one is being presented. The original draft didn't have a transport protocol, and so what's specified there is using HTTPS. And again, coming back from the different use cases and environments that this may get deployed in, the definition right now in the draft uses HTTPS, and again, in prior discussions, the notion of using CoAP was raised. So similar to the messaging in the notion of doing transports, should TEEP be considering multiple transports, and if so, which ones? Is HTTPS sufficient, HTTPS and CoAP only, or should we be doing other ones? Gosh, So comments, discussion.
Andrew is in Miteco, so I'm putting you up. Go ahead, Andrew.
Hi, we're talking about the different transport protocols, and I want it to be clear that it's not enough to say that we require it to use HTTPS or we need it to use CoAP. For it to be meaningful, we'll need to define the format, how the headers work, how the body is formatted, and so on. Because up to now, all I've heard is a discussion of whether we mandate HTTPS and CoAP, but there's a bit more to it than that.
Let's see. I don't know which one of you is up next. If comment on that.
春山兄，黄华伟。For the HTTPS, I have two understanding. One is based on HTTP 1.1 and another is based on HTTP 2. Which HTTP protocol is used?
Ming, do you want to answer?
Do you have an answer you want?
Do you have a preference for which one? I'm presuming it would be the latest one.
Well, not just you have a preference. Do you have a technical argument for one of them?
I can provide some information from the mobile network because I found the wireless product on Huawei. Also, I talk a lot about 4G, 5G. Now 5G have selected HTTP2 to use as the control plane function, and also they select Json to carry out some information. So from my understanding or from my personal view, maybe Json and HTTP2S is more better.
Okay.
So I'd like to remind people when you give your comments, if you think something is better, say why, because this isn't a beauty contest. We're trying to figure out the technical arguments behind it. So for example, it's better because this is what we're already required to use in a global platform implementation, or it's better because this is what is already going to be there in an IoT suite implementation, or so a technical argument is like that. That's what will actually make the big difference.
So Pete, I want to let Ming answer.
I just want, yes, go right ahead. Sorry.
The current draft was submitted to HTTP 1.1, so it didn't get to it yet. But what you say? I hear you.
Okay, thanks.
I apologize, but Hank did want to get one thing in a previous comment. He says TCG starts using CBOR, and just inserted CoAP would also align better with CBOR. So this is back on the format.
Yep.
Okay.
There's
Thanks.
a linkage between these two questions, absolutely.
Which is why we were reminded we're supposed to align to the best we can.
For the IoT case, we are using CoAP, but that concerns more the suite work. So if there's some parallel, it probably draw from there. It CoAP with blockwise transfer, because CoAP alone you can't use because of the size of the payloads. Presumably the size is firmware images on a low-end IoT device may be comparable to a trusted app on a higher-end device potentially, or CoAP over TCP, which also requires, in most cases, makes sense to use with blockwise transfer for better performance.
So just like the comment about HTTP 1.1 versus HTTP 2, those are two different transports, right? Do we need to accommodate multiple transports, or can we pick one, or what is part of the question?
That's a good question. So you could potentially pick one, but of course there are differences in the performance between, and I believe there was even a presentation today during the core working group meeting, because the congestion control mechanism works differently, and so depending on how fast you want to get the data to the device, there would be implications of that. So
Max Burdikin, I don't have a strong preference, but it does seem weird to me that we would discuss HTTPS or CoAP or multiple versions of HTTPS and not tie that answer to the question of what the message format was. So to pick CoAP here and then say it was JSON would seem very weird. Yeah.
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 That's fair.
It's a pair. It's roughly like CoAP and CBOR is most powerful together if you choose so. Yeah.
As soon as this is closed, I guess I have one other question here. Is in the draft, it indicates that this transport is initiated, or it appears to indicate the transport is initiated by the TAM to the device, and I want to make sure that.
No.
from the client app started.
It's outbound.
It's, yeah.
Yeah. Also, with the newer version of HTTP, I haven't seen that being used in the IoT context. So there's 1.1 in that space if used, or some other. Funny enough, some other IoT protocols.
So I've heard a couple of arguments for. I've heard a couple people arguing for why you might consider CoAP in an IoT device. I heard somebody else saying we should just pick one. Okay. And I think I heard an argument as to, but I didn't hear a why as to why we should pick, if you believe that there should only be one, why the one should be HTTPS as opposed to the one being CoAP. Because then you'd be arguing to like preclude IoT or to somehow get HTTPS into an IoT thing. So that's the only one I haven't heard somebody explicitly arguing for on a technical basis.
So
either multiple or CoAP, I've heard arguments for where CoAP seems to, the multiple seems to be the tendency, but I've heard, I don't know.
Yeah, I mean, I kind of hear, yeah. I mean, interpreting that saying for IoT, we would have to use CoAP, whereas today you're using HTTPS. So I'm kind of hearing that multiple would be okay.
So I would just say, yes, I concur some earlier comment on it. Say, for given device, so IoT, and they can choose different from a more resource-rich device, right? Like a phone, sensitive by the power, because they have a lot of tools and library to do the JSON HTTP. Just use that. It's more efficient for that environment. Then you have certain more IT device, a little bit more risk constrained, then you just go to the CoAP and the CBOR. Maybe that's still, the device only need to pick one. By the time, right, you can support both. I think that will be more fit in both, support more optimal in both environments.
Okay, so the option, since they are interdependent, what I'm hearing is, and we'll take it all in the mail too, is to offer the notion of having the TAM support multiple, right? But the client only has to support one.
Yeah. I think what's most important for this protocol is to be sure that we can represent the interest of IoT, even though other can have additional, more rich way of messaging. So I think that we need to use at least two.
Okay, so what I'm also hearing strongly in the group is that we should, I'll say should now.
I think that the multiple is the only option we have because, I'm pretty sure that IoT have some limitations while the others may not, and you don't want to limit the others.
And that's a fair point.
Emerging rough consensus.
Yes.
Scrolling back, this was, who was that?
You are a line.
Oh, it's Hank. Okay. Hank says, first, +1 to max to CoAP and CBOR. That makes sense. He says CoAP over reliable should be discussed more. And that was it.
Okay.
Okay. So I think we're hearing rough consensus, but we'll take it all through the mail.
Confirm on the list, yeah.
Okay, so now the question is, given that we were late in submitting, and Ming, is over there, how many have actually read the draft, the open?
Any version of the draft, whether it's 4 or 5 or 6, yeah.
Okay. You think that's enough?
It's enough to ask a question.
Okay, so let me ask the question here. Brian, you can put your hand down now. Thank you. Should the group adopt the draft as our starting working group draft for the solution? Should we do a hum? Can we get a hum?
Our charter says we'll have a good relationship with global platforms, so we could also say the presumption is that we will and ask for objections. So if people think that there are objections, then we should be discussing that.
Yeah, true. Question.
So Dave Kemp, I would phrase that question as if we were going to align with suit and use an information model, then one alternative would be to take the data structures in this draft, raise them up to an information model, and then use that as the starting point versus using the JSON message format specifically.
But the draft has more than that.
Yeah.
Right? The draft specifies the whole flow.
Right.
Since this draft has already been worked on in global platform and has some implementations in that context, we understand, right? If we're going to do something, we need to choose to say we're either going to use that as a starting point or go our own way and do something different. And so this is, should we adopt that and innovate from there and do everything that we're talking about and any changes or additions based on that or not? Because if it's going to start from someplace else, that's a bigger discussion. So if you're going to argue that no, we want to actually hear about that and hear why.
Dave Waltermeyer, I was just going to suggest that you might defer on the information model question anyway until you figure out if you're going to have a single data model implementation
Absolutely. Yep.
So what I'm hearing is maybe the word "the" is a little bit confusing here because it doesn't mean that the document organization forever will be exactly one document, right? We have a choice to factor it or whatever.
So I will rephrase it to strike the as a working group draft. Yeah.
Brett Jordan, yeah, I would concur with that as well. And I second what Dave said, that I think this is actually a great place to start. So,
Yep.
So why don't you just ask?
Okay, so let me re-ask.
Go ahead.
Should the group adopt this draft, I keep saying that, this draft as a working group item? Can I get a hum, please? Okay, and who believes we should not be adopting this as a working group draft? Hum, please. Wow. I think we have consensus. Okay.
I just wanted to relay a couple of comments from the room.
Okay.
And now I've lost names again. One is, and I'll get back to names because I have to scroll up further. I'm okay with the draft as a starting point, but some larger issues must be addressed. For instance, secure boot definition.
Yeah.
And then starting with draft 6 will ease compatibility with the work at GP. So.
Yep.
Okay.
Yep.
Fair point. Okay, so I think with that,
We've got 4 minutes left. I think that was your last slide.
this was my last slide. So,
So we're at any other business?
any other business to raise? If not,
We wrap up 4 minutes early.
okay.
Did everybody sign the blue sheets?
Did everybody sign the blue sheet?
Anybody not sign the blue sheet? Okay, great.
Okay. I want to thank Pete for being an awesome jabber, long line, and Chris for taking notes.
And Kathleen for helping us get chartered.
Kathleen for, yeah. And welcome, Ben.
Okay, thank you. We're done.
Thanks, everyone. All right, so hold the same for you. Emily. Okay.